No Limits, and today we're gonna talk about growth of function and specifically little o. Okay, what is little o? Let's say we have two functions growing growing different at different rates. Let's say one of the function is f of x and the another one is g of x. What does it mean when we symbolize f of x is equal to o of g of x? Okay, here is what I'm going to explain. F of x or g of x, meaning that f of x grows more slowly than g of x, that is little o meanings. Little o means that the function, on the other hand, is increasing more slowly, and the function that the little o encapsulates, it increasing a lot more than the other function when x approaches to infinity. Infinity means from it can be from positive integers, it can be 1 and going forward. Okay, now if limit x approach to infinity, f of x is equal to f of x divides g of x exists and is equal to 0. What does this statement means? This statement means we say that this f of x is less and increasing more slowly than g of x. So let's say that we have f of x representing 1 and g of x representing 2. When we divide them, we'll get 1 over 2, that is 0.5. So another way to approach this and solve this very simply is by using this property here, f of x divided g of x. And if this yield the answer to 0, then you'll know that your f of x is equal to g of x and the function hold a little o property. And also it must exist. What does it mean must exist? G of x must never be 0 because it will be undefined. So existing, that is what it means. Does not g of x must never be 0. Okay, let's see this statement too. F of x or g of x mean f grows more slowly than g when x is very large. We have already explained that. Okay, let's see how we can tackle each of these questions. So I would like to take this property here. It seems like one we can solve this question very easy. Okay, let's start with x square. Sorry, x square is equal to ox5. Okay, that means we have screen sketch, and we have x square as f of x, so put here x square over all g of x, and we see here all g of x is the one inside, that is x power 5. Then put x exponent 5 here. If you simply divide this, you will end up with something like this. So let's take a simple notation that when x is very large, let's say our very large x is equal to 2, then if you put it down here, we'll get x power 3, that is 2 exponent 3, which is 8, and the above function, which is f of x, will remaining 1. So the f of x growing more slowly than the g of x. Then this function here holds for O for x squared is equal to O g of x, which is x power 5. So this one holds. Okay, let's see sine of x is equal to g o x. Okay, same property. F of x is equal to sine x. G of x is equal to x. Let's say we have our infinity, approaching to infinity, value of x is equal to 90. Sine of x will give us 1 and x will give out 90. So you've seen that our x is very big, but still sine of x, which is f of x, give us a very little value, which is 1, and the g of x is 90. So it is very clearly that f of x increase more slowly than g of x. So this holds true. And another one is this one, 14.709 radical x is equal to or x over 2 plus cos x. Okay, let's attack this very closely. Okay, we have our f of x as 14.709 radical x divides by x over 2 plus 7 cos x. Okay, to prove this very simply, let's just make this simple. Let's say our big X is somewhat 0. Then if it is 0, that means, okay, let's not say it's 0, it's gonna mess up something. Let's say our big X is, let's say 90. If it is 90, here we'll obtain 0, and whole equation becomes 0, so this will cancel out. This will remain 45, and here we'll have 90 inside. So just look at this very closely. 14.709 times whatever comes out whatever comes outside from this one, divide by 45. What will be the answer? So it's very clearly that 45, which is the result from the g of x function, will be very small compared to f of x, which comes from the 14.0 x something. So now this violates our little o, which says that f of x will increase more slowly than g of x. So this one does not hold, and we will check this wrong as it will not hold. Okay, let's see this one. This one is very clear. 1 of x as of f of x and 1. Okay, 1, this just simplify into this. And it is very clearly that our f of x and our g of x, even if we have 90 here, 90 divided by 1 will remain 0 point something, which is very small than 1. So f of x grows more slowly than g of x. Little o holds here. So here it is correct. And we have 23 log x over x 0.02. This one is a bit tricky. Don't overlook it. Okay, let's make things simple, because we have variety of values from x that we say that x increase from infinity. Let's choose our nearly infinity value is 1000. If we put here 1000, then we will have log 1000, and here it will be 1000. Okay, it will have, if we have that, we are going to remain with something like this, 23. Inside here we'll have 3, and down here we'll have 1 1 4 8. So it is very clear that f of x will be growing more rapid than g of x, and this violates our little o notation, and this will not hold. Hence this will have to put here something like this to notify that it is not equal. And you have proven this property. Okay, let's see, this accept, this accepted, this not, this accepted, and this does not. Thank you for watching. I'll see you next time.